Okay, so we're now going back to sets. So we've done a bunch of different proof techniques now and learned about different aspects of logic. And so we're now in a position to start building up towards some interesting results as we go through the term. So let's go back to sets now and look at some more things that we can do with them other than just, is an element in this set or not? And so rather than just, is a single element contained in another set, we can ask if a whole set is contained in another set. And so if we let A and B be sets, we say that A is a subset of B when every element of A is also an element of B. And so we denote this by saying A, and this sideways U symbol with an equality sign underneath, to denote A as a subset of B. In this context, if A is a subset of B, we also say that B is a superset of A. And we can write this with similar symbols just the other way around. Now, finally, we say that A is a proper subset of B when A is a subset of B, but B also contains at least one element that is not in A. And in that case, rather than writing this symbol here, we write the same symbol just without that little extra sign at the bottom. Okay. And finally, we say that two sets A and B are equal when they are subsets of each other. So that is, A is equal to B if A is a subset of B and B is a subset of A. And I've clearly got a bracket in the wrong place here. That should be B is a subset of A. And I'll fix that in the slides that I leave on the website. Okay, so some examples. So for every single set A, we always know that the empty set is a subset of A. And we always know that itself is a subset of itself. Okay. Then, if we have A as a subset of B, that's equivalent to saying that for every element in A is in B. And it's also equivalent to saying that if A is in A, then it's in B. Okay, so these are all equivalent ways of saying the same thing. Then, if A is not a subset of B, there has to be some element of A that isn't in B. Okay, so these are just equivalent ways of saying the same thing. And again, maybe that, rather than a colon, should be a such that. Okay. Now, some simple examples here. 1, 2, and 7 is not a subset of 1, 2, 3, 4, 5 because 7 is in the first set, but not the other. Here we have the set of all even numbers, which is a subset of all integers. And the subsets of 0, 1 are the sets. The empty set, the set that contains just 0, the set that contains 1, and the set that contains 0 and 1. And so this set, or this collection of subsets of a particular set, is a useful object which we will look at in its own right. So the set of all subsets is called the power set. So to give a more formal definition, if we let A be a set, then the power set of A is denoted with this calligraphic, or this cursive P of A. That's the set of all subsets. So as a simple example here, if we take the power set of the empty set, then we get the set that just contains the empty set. The power set of the set that contains just the element 1 is the set that contains the empty set and the set that contains 1, because those two sets are the only subsets of this. Similarly, power set, the set that contains 0 and 1, well, there are 4. There's the empty set, the set that contains 0, the set that contains 1, and the set that contains 0 and 1. Set that contains 0, 1, and 2, well, there are 8 possibilities. The empty set, 3 ways with a single element, 3 ways with 2 elements, and 1 way with 3 elements. And indeed, if you look there, you can see quite a simple pattern, which is kind of obvious, that if a set has a size n, then its power set has size 2 to the n. And this is because each element is either in the set or not. And so we have 2 to the n, so 2 choices for each element. Now, this is pretty clear when the set's finite, but it's much less clear what happens when the set's infinite. And one of the things that we're working towards in this course is proving a very interesting result for infinite sets A and their power sets. And that will be one of the most important results we get to in this course. And we're going to stop there.